Hey guys, welcome back. In the last video, I showed the proof of the quotient rule, and now in this video, we're going to do 4 examples, and I hope you guys will stay for all 4 examples, especially the last one. So, enjoy the video, subscribe to the channel, and continue learning. F of x equals 2x plus 3 over 3x plus 2. I would like in all of these examples for you to find the derivative. So, the quotient rule, let's see how that works. First and foremost, let the reader know that you are about to take the derivative by showing f prime of x. The quotient rule, as you may recall if you saw the proof video, is we're going to keep the denominator, keep the bottom, and then we're going to take the derivative of the top, which is 2. Minus, we're going to keep the top now and take the derivative of the bottom, which is just 3. All over the bottom squared. Now, we are going to clean up the numerator, and we're just going to keep the denominator as is. So we're going to have 6x plus 4 minus 6x plus 9, all over the denominator. Now, we're just going to distribute and clean up. So we have 6x plus 4 minus 6x minus 9 all over 3x plus 2 squared, and that's just going to be negative 5 over the denominator squared. Now this is a typical AP calculus problem where it looks almost the same but just in reverse and so on. Okay, so clean it up, be careful with this minus sign, and distribute properly. Okay, anytime, press pause and try the problem yourself and see if your answer matches my answer. Our second problem of the day is f of x equals x squared over sine x. Remind yourself that this is a quotient rule because there's an x in the denominator and an x in the numerator. So how do we do the quotient rule for this? Keep the bottom, keep the denominator times the derivative of the numerator minus keep the numerator times the derivative of the denominator. The derivative of sine x is cosine x all over the bottom squared. Now there's 2 ways of writing this. You could put the 2 there and then an x, or you can write sine x squared just like that. But you cannot put the squared next to the x without parentheses, okay? So be careful there. Let's clean this up a little bit. There's really nothing to do. You're just going to put the 2x and the sine x minus x squared over cosine x all over sine squared x, and you are done. Please, please, please don't think that you can cross this guy out with this guy out. That is not legal. The only time you could ever do that if there was a sine x here as well, okay? So do not reduce that at all. You can factor out x if you wanted to, but it's really not necessary at this time. So keep the bottom derivative of the top minus keep the top derivative of the bottom over the bottom squared. All right, here's our third question. You guys should probably press the pause button and see if you guys get what I get. Let's find the derivative. It's a quotient rule. Okay, it's a quotient rule. We're going to keep the bottom. Derivative of 3x squared is 6x to the first. The derivative of 4x is just 4. So keep the bottom, derivative of the top, minus keep the top, derivative of the bottom. Now the derivative of cosine is negative sine. So I'm just going to do this, guys. Watch what I'm going to do. I'm going to take this minus here, and I'm going to go plus, and then hit it with the sine x, okay? So all over the denominator squared. Okay, and there's really nothing to do here. So you can just leave it just like that. So we're going to keep the bottom, cosine x, times the derivative of the numerator, minus keep the top. Derivative of cosine is negative sine, so I'm just going to put that plus there. And that's pretty much all for this problem. And now, our favorite problem is f of theta equals tan theta. So now what we're going to do is say f of theta can be rewritten as sine theta over cosine theta. And then you're going to take the derivative as a quotient rule. So you're going to keep the bottom, derivative of sine is cosine theta, minus keep the top, derivative of cosine is negative sine. So I'm going to do the same thing all over the bottom squared. Now check this out. You're going to have cosine squared plus sine squared theta all over cosine squared theta. And if you guys remember the trig identity, cosine squared theta plus sine squared theta is 1 over cosine squared theta. And guys, 1 over cosine theta is secant theta, so this is just going to be secant squared theta. So the derivative of tangent theta is secant squared theta. So now you can add that to the list. Now, I'm going to show you guys the other 3 trigs, but you guys should try to figure it out by yourself using the same exact method. What I mean by the other 3 trigs, right now we know sine theta, cosine theta, and tan theta. And now you guys need the reciprocals, cotangent theta, cosecant theta, and secant theta. So you should try using the quotient rule and figuring them out. All right, so that's all for this video. Come back for some more videos on quotient rule, trig identity, and then the chain rule.